Hello everybody, I'm Nick, and in this video you're going to see how you can write integration tests when using dotnet Aspire. Now, dotnet Aspire launched with a bit of an identity crisis, but it is here to stay, it's being ironed out, and Microsoft is actually using it, which is the biggest metric you should be looking at on whether something should be sort of stay or not. No shots fired to any other technology. Now, this topic is something that I'm very deeply interested in, and I haven't really investigated it that much, which is why I invited my good friend Guy Ferreira, who's a YouTuber and also Dome Train author. He's excellent at what he's doing, and his focus is testing. So this is the best source to learn more about this subject. He has a YouTube channel, link in the description. Subscribe to him if you like what you see. You seem to like his videos whenever I have him as a guest on my channel. And he's also a Dome Train author, talking about things like writing testable code. In fact, you can use code SUMMER30 at checkout until the end of summer to get 30% off every course, including Guy's courses and mine as well. Now, Guy, take it away.
Thanks, Nick. Aspire is great to build a distributed application, but also to test it. And that's exactly what I will show you today. But first, let me explain you how it actually works. There's something different from running a regular integration test, something that will use something like the test server, the web application factory, runs things in memory, stuff like that, or using Aspire. Let me try to sketch out what is happening when you are building tests with Aspire. Imagine the following. This is our test project, our Aspire test project. What will happen is that project, this test project, will basically start the app host from Aspire. When you create your .NET Aspire application, you will have the app host. This is the one that it will start. This arrow represents the starting of that host. What that will make is that it will run the individual resources that you have in your application. So if you define that the app that you are configuring using Aspire as a Postgres database, for example, the host will run it. You will have, for example, your API, and once again, the host will run it. By using Aspire, as you know, those two have a relationship between each other. What does that mean? It means that when you are starting this thing, you will tell the app host that you want to run the tests. It will start all the resources that are needed, database, caches, APIs, front ends, every single thing that you have defined on your app host in the defaults. And then what will happen is that you can now start performing requests. So if this test needs to perform an HTTP call to that API, now it can do it. The biggest difference between this approach and using something like integration tests using test server, web application factory, is that this is not running in memory. This, in fact, is a different process that is running. Okay, so it's like running Aspire regularly, and each one of those resources, it's a different process. So it's not as part of the test itself. Okay, it's not being hosted by the test. So it's a bit more close to the reality, let's say. That brings some challenges or some limitations. And why do I say that? Because you can't do exactly the same type of things as you do with the web application factory. Or if you want to do them, you need to do them in a different way, but we'll talk about that later. Important thing, one of the biggest differences between running the tests the way that I will show you through Aspire is that once you start the app host, it will not start some things that usually start when you do the start of your Aspire configuration. Things like the dashboard, that beautiful dashboard that you have when you run the application, and you can see the observability, the metrics, and all of that stuff. All of that is not being started when you run it through the tests. So you can see this as a kind of like a lightweight approach for the sake of testing. You have some entry points for configuration that I will explain that as well. And also keep in mind that this is different than what you used to have to test things like APIs. And the advantage here is when you want to test something like the relationship between two services. Imagine that you have the API and, for example, an UI. What will happen is that once you start the host, it will run the UI as well. You can have the UI performing some requests to the API as well. So if you want to perform a test that instead of going through the API, goes through the UI, talks with the API, talks with the database, and goes back, and you assert that every single thing is fine, This will all be coupled together. Once you start it, you have all those definitions in place, and you can check that those services are interacting properly. So this leads us to a different type of testing, okay? I don't see this as a replacement for integration tests as much as the Microsoft documentation tend to lean on, I would say, because in some places you will find the idea of integration testing. You can use it for a given type of integration test when it's a broad scope integration test. However, I can see it more as a replacement for things like end-to-end testing or functional testing. So enough boxes and arrows, let's take a look into the code. What we have here, we have basically the quick start of the Aspire application. If you go through the documentation and you follow the quick start steps, you will get this. There's a small difference, is the fact that I added here, for the sake of the demo, some endpoints to manage to-dos, okay? So I can list them, I can find them, I can add them to where? To a Postgres database. So if you go here into the hub host, you can see that we have Postgres as well, and that Postgres database is a reference to the API. So the API resource, has a reference to the database resource. And my goal now is to start building tests that will interact with those endpoints to work with those to-do items. But before doing that, I will show you how to set up the project for those tests with Aspire. What do you need? First, you need to have installed the templates for Aspire. If you don't have them, you can do them quite easily. You can either install it through the extensions and plugins of your IDE, or open your terminal and run .NET new install Aspire project templates. I already installed it before, but you can see here that we have 3 particular templates that are interesting for our use case: the MES test 1, NUnit 1, and XUnit 1. All of them can be used for this that I'm about to show you. I will be using the XUnit one. Why? Because I want to create a project for testing using XUnit. If you want to do this through your IDE and you have the templates available there, you can do it. The way that I will do it is that I will create it through the terminal. So that means that once you have that template installed, you can go to the place where you want that project to be and then simply run .NET new aspire-xunit. This will use the aspire-xunit template to create a new project. Inside of our solution, now we have the Aspire sample tests, that is the one that we just created. If we go to the CS proj, we can see there the package reference to the Aspire hosting testing, but the first step is to add a reference to the app host. So you can do it manually or simply use your IDE. Okay, that will add that reference here, okay, and now we can start running our first tests. As part of the template, you will get this default file, okay, this first file, an integration test 1. And here you can find some of the instructions, but let's remove the first one. We already have done it, but I will uncomment this test, because this can be the starting point to show you how to run the tests and what happens when you run the tests. If you uncomment that code, first thing that you need to do is to fix maybe the name of the project. So here you need to point to the app host, and now the test will compile. And what we have here, this await distributed application testing builder, when we do the create async, is the one that will allow us to start interacting with our application. So you can see that we first have the app host builder, then we'll add some configurations, configure the HTTP client defaults, because we are adding this resilient handler. Why? As I explained it before, we will interact through the network with those processes that are running. So this is slightly different than running it with the test server, for example. Then what we have, we do the app host build async, provide a cancellation token, and also we have this await async with a default timeout. Why? We are basically doing in those 2 lines the following. We are saying, let's start this infrastructure and let's wait for a given amount of time. Then we'll start testing this thing. So basically, we want to be sure that those processes are already running. Okay, when we do the start of the Aspire, it starts with all those resources. This default timeout is something that you might want to adjust depending on the complexity of your infrastructure. Maybe 30 seconds is not enough, depending on your machine, for example, where it's running. So this is the limit that you wait for that configuration, that infrastructure to start. Then once we have that, what we'll do, we'll use that distributed application that we get from building the app host. And there, notice we can start creating HTTP clients just with the resource name. What is the resource name? If you go into the app host, you can see that I gave the web frontend name to this resource. That means that that test will basically create an HTTP client to the front end. Then we'll wait to see if that front end is healthy. Why? We want to make sure not only that the process is running, but that the web front end can accept requests already. And once it can receive a request, we'll basically call the root of that endpoint and check the status code. So this is our first test. If we run this thing, you can see that I can still take a look into the test explorer if I have it. And I want you to take a look into something. Notice the containers are starting and now they are finishing. What does that mean? It means that the process of running those tests will manage that for you. If you have used something like test containers, you are familiar with this approach of starting the infrastructure for you. By the end, you destroy it and every single thing is fine. So it's exactly the same idea, okay? And you can see that the test succeeded. It took some time because it needs to bring all of those things up and then destroy them. But now what we'll do is to bring some tests here to test those to-do endpoints. So let's say that I want to test that endpoint that I showed you before to get all of those to-dos. How can I do it? Let's start with a simple way, and then we'll start understanding what we need to improve in order to have this in a more professional way. So if we want to test that, maybe it can be something as simple as duplicating this test. Let me collapse this thing. And let's bring a test like get all to-dos, return an empty list. If we look into every single thing that is here, what we need to change, okay? It's the same project that we are building, the same Aspire configuration. So every single thing until this moment should be exactly the same. The difference should be from this point forward. What we need to do, we have this create HTTP client that is trying to get an HTTP client to the web front end. So what we need to do is to go to the app host and find the resource name of that API service. So if we go back into our tests, we replace this, what it will make, create an HTTP client for that API service, wait for that API service to start for a given time, and then perform an HTTP request. On that case, we want the to-dos endpoint, and also I want to deserialize the content on my response in order to do some assertions. One thing that I can do here is to add a reference to the project where I have those objects, that is the API service project. And this way we can do something as simple as this, okay? It should be empty. I didn't create anything yet, so it should be empty. If we run those tests now, the same thing will happen, okay? It will start that infrastructure, run the tests. However, this approach has one problem, what it is. As you can see, each test is taking a ton of time. And why? Because on each test, I'm calling that first part that we have here of distributed application testing builder, create a sink, do all of that stuff, then do the build a sink, then do await a sink, start a sink, await a sink. If you have used something like test containers, you know that you have the moment of building that configuration, then starting that configuration. Basically, the same thing is happening here. What does that mean? Each test is starting a complete infrastructure for running those tests. So what can we do to simplify all of these things? You can take advantage of any of the approaches that you already have available on your testing framework. If you are using XUnit, you can bring fixtures to help you out. Since I know that these two types of tests are two different types of tests, so I have one to the web application and one to the API, to the to-dos, I will decide to to use something like a collection fixture, because that way I can guarantee that I only start this configuration, this setup, this distributed application only once. Then I can run my tests. By the end, I dispose them. What we'll do for that is to bring a new class, and on my tests, I will create one named Aspire App Fixture. And an important part is that that class should implement the iAsync lifetime. Why? We'll need to start those processes, those containers, and we'll need to make sure that they are disposed. So the ideal way to do it with XUnit is by using the iAsync lifetime. And there's one more thing that if we look into the tests, we can try to bring into the fixture. That is, if we look into all of this code, we can see that until this moment, it's basically always the same thing. Okay, we are always doing this either here or here. So all of that code can go to the inside of the fixture. So on the initialize, what we'll do, configure the cancellation token source, call the distributed application testing builder, add the logging, standard resilience handler, start the host, build the host, and start the host. What we need to do as well is to dispose that infrastructure. So let's make this async and let's await the dispose of the application. This will guarantee that I only start this once. Now we can start to take decisions like, do I want each test creating the HTTP client? Do I want to reuse the same? So my approach will be to create a different HTTP client here for each type of application, each resource that I'm trying to communicate with. So I have two, the front end and the API. So I will do it exactly here. Let's bring those two HTTP clients. And once we know that the application is already running, we'll create the HTTP client, keep it here, but also do that resource health check to make sure that we don't move forward while those two APIs are not running, okay? So this way, I do all of that process only once for both APIs, then I can start running those tests. The only thing that is missing here is to create the fixture, the collection fixture. How do we do it? You might be used to do it with XUnit, create a collection definition, give it a name, and also create a class, implement the iCollection fixture, Aspire App Fixture. With this in place, now we can go into our tests, bring an attribute, the collection attribute, assign it to that collection. That means that this will run in the same context. So of that collection, it will always start that fixture and only then run this code, then run the dispose. And also we need to move away or throw it away all of that code. So we delete all of it, but now we need the HTTP client. How do we get it? Okay, it's simple. We can bring a new field for the Aspire app fixture, get that fixture through the constructor, and that will give you access to the web client and you can perform the request. Also, it makes sense to move this test to a different place, to a different file, to a file only with those tests regarding the to-do. So let's quickly do that. Create a to-do API tests on that collection and bring the test in without all of that stuff that was there that we don't need anymore because now it's part of the fixture. Okay, it's quite simple as you can see. That means that if we go here into our tests and we run them, now we'll see that they are in two different classes. What will happen now is that it will only start the infrastructure, the containers only once, run those two tests and close every single thing. So we optimized the utilization of all of that infrastructure. We improved the speed of running those tests because we don't need to wait as long for the infrastructure starting for one test and for another and for another. So we can reuse the same infrastructure. So if you want to bring other types of tests, you can do it. I will quickly do it. And here they are. And what I have here, basically all of those scenarios like creating to-dos, updating them, deleting them. And you can see the type of scenarios where this makes a ton of sense. Because I'm testing this from the outside. It's an external process. I'm communicating with the available interfaces to talk with this application. And I'm testing something like a simple flow of creating a to-do item and being able to changing it. For example, making sure that I can get it to see if it's in the status that I want. I can do all of those flows if needed. And the cool thing is that by doing this is communicating with different resources that it has a dependency on. I have some more tips for you. As an example, on something like this, where you need to wait for a ton of resources to make sure that they are already healthy before proceeding with the code, you might want to, instead of going it line by line, like in this case, you have a wait for this resource, a wait for another resource, you might want to use something like the task when all, okay, and only then you start it, okay? Just a small detail, but it might make the difference, especially when you have a ton of resources. Another thing that you can do with Aspire is, for example, in scenarios like this, where you have an API to post something and it will go into a database. And let's say that you don't have an endpoint that you can assert the thing that you are looking for. Okay, you know that that thing will go to the database, but you have no way to assert the status, you have no way to check that the data is correct. You can always do something slightly different from the one that is here, that is taking advantage of the fact that you have the fixture. And there you could use the hub host to do something like the following. Let's say that you want the API. So you would say that for that API that you'll get from the app host, create resource builder, you say it's a project resource and you give it the name here. Let's say that the name is API. On my case is API service. So for the API service, now you can go to the API resource and get the environment variables. Okay. From this, you'll get a dictionary. You can go to the dictionary and find, for example, a connection string to a given database. And then you can, for example, open the connection to talk with that database and check that the things are there. Okay. It's not my favorite way of doing things, but it opens the possibility because you can interact with the resource and see the configuration of that resource through this configuration that you have here through the distributed application testing builder. There's something else quite interesting that you can do through this code. As an example, when you do something like integration testing, it's common to take advantage of configurations or the environment to replace the configurations that you are using for a given resource, for example, for a given dependency. I don't think this is the ideal scenario for Aspire. However, there's the possibility to reach the same thing without using the same tools that you use with Web Application Factory. For example, here, when we create the async of that project right through the distributed application testing builder, you have these arguments, okay? And through those arguments, you can provide something like this, an array of strings, and I'm saying that the environment should be testing. That means that on the code that will be running, I can have a condition to check, am I running in test mode or not? And based on that, I can change the things. If I don't want to change the environment, there's another option. Example, let's say that you have something like feature flags and you want to assign to that feature given value, for example, saying that those tests, it should be enabled. You can provide it like this. And then in the code that will be using it, for example, let's say that I'm here trying to configure my application, I could do something like this. I could, for example, go through the builder configuration, get value, give the name of the feature that I'm looking for, provide a default value, and it will assign to that variable. And then I can use it to influence the configurations on dependency injection, configuration of a given dependency that I have, anything that I want. Another important thing that you should know is that if at a given point I want to set a breakpoint on one of those tests that is using Aspire, I can do it. I can set the breakpoint either on the test or inside of one of those resources, and it will work as you are used to. While this is a great technology in my opinion, I don't think it's great for every single type of test that you are doing. And we might have the problem of trying to fit it in a given type of tests, and eventually we'll realize that is not ideal for that. For example, unit tests clearly is not the point of this technology, okay? Unit tests should be something connected with the code that you are using, is for those small details, for all of those possibilities that your code can go through, all of those corner cases, all of that kind of stuff. Integration tests is something that by looking to the potential of this technology, you might think that is ideal. In my opinion, is not, because I feel that when we are doing integration tests, we need a bit more of control on the dependencies that we have plugged in or not. And since the way that tests with Aspire work, we go through the outside, we have the processes running, we have the infrastructure starting, and we are most kind of like in a black box, right? So I don't think integration tests is the place for this. Where I think this shines is on those on the top, the end-to-end tests. Also, if you are doing something like acceptance or either functional, they are kind of like different names for kind of like the same thing. So if you are doing one of those types of tests, I think this is really great. Why do I think it's great? For a simple reason. You have something that is quite close to the real infrastructure in production. And now, instead of waiting for deploying this to something like staging, and then you have a shared environment and everyone is running the tests against it and might impact each other, now you can reduce the feedback cycle and have the developers running the end-to-end tests on their own machine, what is extremely powerful. Obviously, you have to balance here the confidence and the speed. That means that you don't need to do as much tests on that type. You should be doing a ton of tests on the other types, but to cover kind of like a functional way of your application and end-to-end view a given feature, it's great. It's great. And also you have the byproduct of ensuring that your application will talk with the real technologies in a proper way. They are properly configured, the resources are well configured, and the relationship between them. So I think it's extremely valuable and has a ton of potential. Before we go, let me tell you something. We have been using collection fixtures from XUnit during this video. However, there's a new version of XUnit available, XUnit v3. XUnit v3 brings a new feature named Assembly Fixtures. That feature is great to replace many of the use cases where we use something like the collection fixture. So this might be one of those cases. So if you are curious about that, Nick has a full video on all of those features available on XUnit v3. I have a video specific on using assembly fixtures, so you might want to take a look on that. And if you go there, take a chance and subscribe. So this is all that I have for you today. Thanks, Nick, and keep coding.